take a look at some of the measuring devices which are involved in you can see that it says that the device will measure to 1 million volts. It goes to 10 megahertz, and with the proper voltage divider, there's a 400 volt divider that's sitting beside it there. There are dividers which go up to about 5 million volts. That's the conventional way to measure it. My preferred way to measure it is with a magnetometer and electroscope, various sorts of devices that measure magnetic fields, and the magnetic field is directly related to the amount of amperage that's present. If your amp turns and your coil represent a magnetic field, and it's very measurable, and it's a very safe way to go. Here's one form of voltage divider. See all the resistors that are hooked in series and parallel and everything else, and then you have the thing on the top there that helps dissipate the energy so that you don't burn everything up. LCR meters can get pretty sophisticated. This is one of the more sophisticated ones. That's from Stanford Research Systems in California. Here's for people that just want to find out if this sort of thing can really happen without spending very much money. Here's what $50 will get you. We were talking about the separate coil systems a little bit ago, where one was running and the other would copy the amount of power on it without depleting the energy from the first one. That's what this is made to demonstrate, and it's used in physics classes in high school and college. And what happens is that second block there, which is in no way connected except by the radio frequency, will light a conventional 60-watt electric light bulb. The input on this is 1.5 volts over on the left-hand side there. 1.5 volts input on the left-hand side powers that coil system that's on the block on the left side, and you can move this other coil some distance away, and you can hook an electric light bulb onto it, or 60. It comes with a 60-volt neon tube which lights up whenever you tune the frequency of the second coil to match the first coil. So that demonstrates one of the. There's the hookup information showing how the two blocks work. So that's your basic wireless transmission of energy device. see here if we can do some zooming on this one. Okay, this is one of the early ones showing the transistor that's being oscillated by the capacitor, variable capacitor, and variable resistor in the back of it. And the number 7 thing actually happens to be a high voltage transformer. That could be your the one from the television set, the kick flyback transformer from a television. It can be the transformer from an automobile, one of the early ones. And the number 6 down there is basically an off and on switch down at the very bottom in the middle. It causes coil, or number 9 there, to react, which in turn number 11 over there can be tuned by the grounding capacitor so that it will match the number 9 deal and it will become active, so your energy will be coming out on number 12 there at the top and the bottom one down below. Now you can center tap this thing and you'll have your amperage and hook it up like we were talking about. Now, this is the one that postage card size one that will run an automobile from say maybe a 6-volt battery, flashlight battery, not automobile battery. And it's one that can also recharge the battery so that the battery basically never runs down. We were talking about voltage dividers. This one I'm going to have to put it on in more than one position because you can see the man down below. Okay, I'll turn him sideways and so you can see it. The thing is over 12 feet tall. The man is 6 feet tall. So that's used in your mega voltages. You don't have to use that at all if you use my system of magnetic fields and electrostatic and electromagnetic field measurements. You don't have to use that at all. Okay, this is something that we can thank Romania for this. This is from a translation from a book in Romanian, which I have or had, that tells what happens in magnets, and a Tesla coil or the center tap on the Tesla coil behaves just exactly like this magnet. The block wall system there becomes the negative or earth ground, and that's the place where the electrons are getting organized, and on one side they spin right, the other side they spin left. And you can take your hand and cusp it, and the direction of the apparent direction of electron movement would be like in this plane, and the spinning would be around that particular plane. And then on the other end of it, you have to reverse